Hi, my name is Jason Gabriel with Mount Baker Mining and Metals, and today I wanted to do a video on smelting. We get a lot of guys who ask about what to do with their black sand concentrates off the table, and they have high sulfide concentrates in their number 1 and number 2 high grade after they pan out all the free gold. I wanted to do some experiments here, get them on video, and I'm really going to be interested in some comments and tips from you guys who have some more experience with smelting than I do. So I'll show you what I'm going to do, how I'm going to do it, and all the tools I'm going to use, and see what you guys think. Here's some of the high-grade concentrates that come off the shaker table, and this is the number 1 and number 2 port, and I've panned out all the free gold. And I'm not going to roast this stuff. I'm going to smelt it as is. And the strategy there is I'm going to actually have the matte form, and then I'm going to reprocess the matte using a different flux. But the reason I'm doing that is because it's really hard to roast a bunch of material. It's fairly easy to roast about a quarter cup or half a cup. But when you want to do pounds and pounds of material, it actually takes a really long time, and you got to have it all exposed to the oxygen in the air, and you got to get it about 12 or 1300 degrees Fahrenheit. So I'm going to try and force it into a matte phase through the first smelt, and then after the first smelt, I'm going to take the matte and reprocess it using potassium nitrate, which is a very extreme oxidizer, and some iron filings, so I can avoid the roast. I took 1 cup of the high-grade number 1 and number 2 and mixed it with 2.5 cups of Chapman flux, and I added about a pound of fine copper wire to the mix as a collector metal, because I found that if you don't have enough metal in the charge, that when you pour your material in your conical mold, you don't get any button at the bottom. It all stays suspended in the slag. So you need a collector metal to filter down through the material and capture the gold and other precious metals, silver, and bring it down to the bottom in a button, or it actually turns out to be a little pyramid. So I use copper. Lead is another one. Lead is the one they use in fire assay, but a lot of guys want to stay away from lead because it's toxic. A lot of companies won't take lead and refine it, whereas copper gold refining is fairly common and easy to do. And then I'm going to put another 1 pound of fine copper wire on top, so as it melts it'll trickle down through and act as a collector metal. So here's the Chapman flux recipe that I'm going to be using. The sodium tetraborate is borax, and it's covered up there a little bit, but it's 40%. Sodium carbonate is soda ash at 20%. Silica is just quartz, and manganese dioxide as an oxidizer. Here are the 2 other pieces that we made to go along with this. This is a little conical mold we made. You can pour a number 10 crucible in there, and it comes just right to the top. And then these are just some tongs we made for getting the crucibles in and out of the kiln there. And like I said earlier, this is really a kind of an R&D experimental project. I got the kiln for a couple different reasons. One, it was fairly cheap, but also you can put a really pretty good sized crucible. It's actually sitting over there. I have another segment that can go on top of there, so I can actually probably put about a number 80 or 100 crucible in there, and so I can do a really big smelt once I get the hang of it for in an oven that's real cheap. I probably have less than $500 in this whole thing, including crucibles and flux. So we'll take a real quick peek in here. I don't know if you can see anything in there, but I'm going to give it a stir here, and then wait another half an hour, give it another stir, and then we'll pour. here's our conical mold with the pour in it. So we'll let that cool, and we'll dump it out and see what the collector metal looks like. So there you go, a couple taps on the table, and the slag and stuff fell out of the mold, and you can see the copper and metal all came down to the bottom, and then the slag is sitting on top. So I've broke our 3 different phases apart here. Here's the metal pyramid at the bottom of the cone. This section right here is the mat that formed. It's the artificial sulfide because it didn't all get oxidized because we didn't roast it. And then this black stuff up here is all the slag. So here's our copper pyramid from the smelt we did. And it weighs 1 pound, 2.75 ounces. And I went and polished this side of it here and had it analyzed with an XRF gun that a friend of mine has. And I think I can post a picture of the results. So by doing the math with the results of the XRF gun, I can calculate the amount of gold that we recovered. And we recovered right about 8 grams of gold by doing our copper collector metal smelt on the number 1 and number 2 table concentrates. So here's the composition of the potassium nitrate flux I'm going to be using to process the mat. And you can see there's quite a bit of borax in there, and I'm going to add a little bit more silica. So here's a look at our potassium nitrate flux, and here's some of the iron filings I'm going to be using. And I'm going to add about 1 part flux, 1 part iron shavings, and 1 part mat, and see how it goes. Now here's a separate smelt I did on the mat that was recovered from the first smelt we did. So I took all the mat from the first smelt, broke it off, and re-smelted it with some potassium nitrate and iron filings. And you can see I didn't use any copper, but we recovered quite a bit more copper from the mat. By adding iron filings to the smelt, the iron removes the sulfur from all the different types of sulfides in the mat and forms FeS, which is then soluble in the slag. And the only problem I had here is I added too much iron and not enough slag, so the slag couldn't absorb as much iron sulfide as I added, so it essentially formed an iron sulfide mat here, which is okay because most of our precious metals and our base metals ended up down here in our copper button anyway. So it was a successful processing of the mat from the first smelt, and we got away from roasting any of our sulfides. So I really appreciate you guys watching my video on smelting, and I'll be really interested to hear from you guys about some of your tips and tricks on how to smelt and how I can improve my process, because like I say, a lot of our customers are really interested in the process about how to recover some of their gold from the concentrates they get off the table once they get all the free gold out. I will also post some links in the description of the video that I found really useful when I was trying to figure out how to get this whole process figured out. So be sure to check those links for more information on smelting and fire assaying. So again, thanks for watching, and feel free to email me with any questions or comments you guys have. Also, be sure to post your comments below the video